Here's my work solutions for the Pearson Edexcel higher paper from the November 2019 series. As you can see, it's paper 2 this time. That means calcs allowed. Let's get on with it. Question 1, nothing major here, nothing to overly waffle or explain about, so just do the quick version. For a frequency polygon, once you've had a look at these questions, you always check the heights first. That's the first thing to mention. Have they done anything really obvious? You can tell that is your first extremely obvious mistake. So a sentence which says shouldn't have joined the endpoints, or shouldn't have literally created a polygon. Once you've checked the heights, they've used the midpoints for the frequency polygon, which is correct. You use the endpoints for a cumulative, so they've got that bit right. But what's another key thing that's missing? There's no frequency label on the y-axis. So again, whatever's there basically should be there. They've not done it. So it's missing labels on the y-axis. Number 2, when you're dealing with errors and bounds, whatever you've been rounded off to find your upper and your lower limits, you go up and down by half of the rounding amount. So to go up and down, you go up and down by half a millimetre. Add a 0.5 on the end to get the, add a 0.5 on the end to get the upper bound, subtract a 0.5 off the end to get the lower bound. The mark scheme does accept, and maybe you've been trained for the 4-9 recurring bit, because technically that's what the answer should be, 0.49 and 9's forever. But as you may know from sticking that in your calculator when you're bored, if you hit equals after putting in, let's say, 50 odd 9's, hit equals and your calc returns the 128.5. So both are acceptable for the upper limit and obviously not the same for your lower limit. Number 3 is extremely waffly. It's ratio/fractions for me are the key. One thing at a time. Tom and Adam, stop right there. Get your thoughts organised. The ratio is 3 to 7. That's 3/10 to 7/10. Grab your calculator, get them worked out. 240 times 3/10 means he gets 72, and he gets the rest, 168. We now move on. Tom and Adam buy some stamps off each other. In other words, there's still 240 available. The ratio is now 3 to 5. That's 3/8 and 5/8. And you can work out either of these times 240 or both. It's entirely up to you. I've done both, so I'll mention both, because as you'll be able to see, that's gone down by 18, sorry. That's gone up by 18 because that's how many they've bought and sold from each other. Next. Again, a little bit waffly, but always one line at a time. Each person's going to get a free gift. Stan's going to order the gifts. Takes a sample of 50 people. So you're working out of 50. There are 700 people in the fitness club. Now, when you're doing an expected amount, you work on the fraction which you know. So it's sports bag. That's the fraction in Stan's sample who said sports bags, and of means times the 700 people. Again, reach for the calc. That means 238 people. All right, work out how many sports bags Stan should order. There we go. Write down any assumption. Can go lots of ways about this. The key words you want to get in, you want to either get it is representative, as in the sample that Stan's done is representative of the 700 people, or try to get in the word proportion and say that the proportion of people in Stan's survey is the same as the proportion of the whole. As I say, so the two key words when you write your sentence: don't waffle, don't use 4 lines. As always, 1 mark, 1 sentence, it's representative or it's in the same proportion as his sample. Number 5, let's just do a bit of revision before we actually look at the graphs. Let's not forget the shape of these things. That's your basic quadratic. That's a form of a cubic, the roller coaster up and down. That's your reciprocal graph. And I will just say, that's your cubic when there's more of it, when there's squares and so on. Down here, that's your extremely basic cubic, where it is just y equals x cubed. You can have a multiplier in there, but there's certainly nothing else over here. This is also your reciprocal graph, so there's your problem. They're different. And why is that? Because this one up here is upside down. When something's upside down, it's been multiplied by a negative. Okay, so be careful on that. Your standard reciprocal graph is graph D, and that's why we'll slot that in there. E, standard linear graph, so something of the form y equals mx plus c. Always worth doing them while you're revising, because in the exam, these match up things for Edexcel. They're very, very common. So always run through sin x, cos x, exponential graphs, and the like. Just run through them like that before you pick. So y equals x cubed, as I've said, we can eliminate b, because there's much more to it. It's got 3 solutions. There's much more going on in b, and that's why that graph is f. Number 6. I prefer a brute force approach to this. Now, the way I've set it out, it's worth 3 marks. Slow it down, no rush. Take 4 or 5 minutes for these. They're nice and easy. You've got your calc. One of the sequences is 2n squared minus 1. Now, a quick glance at that, you'll know it's just going up and up and up. That's what's going on. It's an n squared. Think of the nx squared graph. This one's a subtraction. This one's an upside down. That's going to just go on. So at some point they meet and will never cross again. That's the key. Let's try some values for n. Use your calc, use your knowledge of BIDMAS, stick in the 1. 2 lots of 1 squared is 2. Take away 1. There we go. Or use your calculator. 2 squared is 4. Doubled. Take away 1. 3 squared is 9. Doubled. Take away 1. 4 squared is 16. Doubled is 32. Take away 1. And 5 squared is 25. Double it. Take away 1. Let's see what's going on here. It's basically 40. Take away your square numbers in turn. 40 take away 1 is 39. 40 take away 4. 40 take away 9. And 40 take away 16. And as you can see, I've slightly got my lines out of order. When n is 3, okay, on that 3rd line down, and that 4th line down there when n is 4, you get the answer 31. 31 is the number which appears in both of the sequences, and it says show there's only one. Make a little summary statement. You could carry it on further if you wanted to, but make a little summary of a statement down there, as in 1 will continue to increase and decrease. They'll never cross again. If you wanted to just quickly sketch it, the idea is something like 1's doing that and 1's doing that. They've crossed and they're never going to cross again. We don't need to look at negative values of n. But yeah, Plenty of ways to explain your way out of that one, but I do like that table approach. I call it a brute force approach, where you basically just keep going, you just sub loads in. But it's not that bad, really. Number 7, if you stick the whole thing in your calculator, depending on the make and model, it might just get you there. But this is worth just doing a half sort of revision of laws of indices and standard form and so on. Do the numbers first. That's the bit where I definitely pick up my calculator. Do 3.42 divided by 7.5. Gives you a number which is not in between 1 and 10, but we'll worry about that shortly. When you divide, you subtract the powers. You should be pressing -7 is where it starts. Divide means minus, and it's -6. It's a double minus in the middle, which means it's really -7 plus 6 takes you up to -1. But that's not in the standard form. We need to make this number bigger, so we are timesing it by 10. But to balance up, we should be dividing by 10. And if you want to divide a number by 10, you make the power smaller by 1. As I say, some calculators will have got you there straight away, but you're doing these past papers for revision, aren't you? So there we go. Number 8, waffly for what I see as quite an easy question, if I'm honest. You've got one of these connections. Just switch around, multiply both sides by n, divide both sides by d. That's the form you need, because it's trying to find out the number of workers. It's currently in the form with d being the subject. It's finding the number of days when you stick n in. In this form, we can crack on. Ali's company takes 40 days. 720 divided by d is 40. Means that Ali's company would take 18 days. On to Haley. Same approach. 720 divided by the 30 for her company. You get 24. Haley's company will have to use more workers. How many more? Nice and obvious now. Done all the hard work. And on we go. Number 9, there's a lot to this one. But again, follow the process. When you're looking at cubes and cuboids, there's really only one question to ask when you look at it. Are we talking volume or are we talking surface area? Just so happens this one's both. You're told that the total surface area of the cube is equal to the total surface area of the cuboid. We know nothing about the cube, other than all the faces are the same, and there's 6 of them. So you've got to start working on the cuboid over here. So surface area of the cuboid. If there's a top, there's a bottom, front, back, left, right. So we need to double each side. The front is 8 times 6. The side is 18 times 6. And you've got the top and the bottom is 18 times 8. If you're paranoid, put extra brackets around, but BidMaths will work the rest out. And you should be getting 600. You don't need to write the units at this point, but if you're ever doing a question and you find yourself getting lost in the question, as in, I've worked a number out, I don't know what that number means. That's why. Keep the units in your question, helps you know where you are. If 600 centimetres squared is the surface area of the cuboid, that's also the surface area of the cube, which is the area of all the surfaces, of which there are 6. 600 divided by 6 means each face is 10. Sorry, it is 100, which means each side is 10. It's a 10 by 10 cube. that will have a surface area of 600. We can now move on to Janet. The volume of the cube is 10 times 10 times 10, 1,000. The volume of the cuboid. Whoa, what am I doing? Is the 3 dimensions multiplied by each other. Calcs at the ready for 864. Is Janet correct? You've done all the working out. You now just answer the question with a no. No point in adding any more on to the end of that. Number 10, rearranging formulae, also known as transposition. Always do the same to both sides and get rid of all the nasty stuff like square roots by squaring the left and squaring the right. On the right hand side, as you can see, it just means it disappears. To make K the subject, you want K equals not minus K. So I'm going to add a K to both sides first. And then subtract y squared from 2m, y squared from both sides, and we've got K as the subject. And there we go. Number 11, good old box and whiskers. Let's just remind ourselves, because it will come into play. Whenever you've got a box and whiskers plot, it's 3 quartiles. Lower middle quartile is actually the median, and upper quartile, and it means that 25% of your data is in each quarter. Each quartile splits data into quarters. That means Megan says that half her potatoes weighed less than 50 grams. She cannot be wrong. Sorry, she cannot be right. She's totally wrong because her median is 57. Is Megan correct? Absolutely not. And you can say words like, that would mean her median is 50, which it isn't. I prefer to, well, if someone's done something wrong, best way to show it is do it right. Half Megan's potatoes weigh less than her median of 57. All right, you don't need to over waffle, take 3 lines or any nonsense like that. Amy also grows potatoes, so Amy versus Megan. Compare the distribution. It's worth 2 marks. You need to say 2 things. The first and most obvious is you compare medians. Straight away, Amy's is 42. We already know what Megan's is. You need to say something like, Megan's potatoes, on average, are heavier. Or say just straightforward, Megan's median is higher. Megan's 57 is higher than 42. Just get those numbers in. You've done some maths. Get those numbers in. Second thing, if you compare the ranges, they're actually quite close. The lowest is like 23 on each, and the highest is 72 and 70. So yeah, Megan's range is slightly bigger, but there's much more of a difference in the interquartile range. Megan's is there, Amy's is there, it's much narrower. So I would prefer to talk about the interquartile range and not the range. Again, do some calculations. Megan's IQR, Megan's interquartile range is 26. Amy's IQR is 16. And for that kind of data, that's quite a big difference. So something like Megan's IQR of 26 is much bigger, which means her middle 50% is more varied, or there's more spread. Try and get some context into there as well. Number 12. Some tricky looking trigonometry, as you can probably guess. Whenever you see triangles, always look at how many marks it's worth. If it's worth more than 3, you're probably going to have to do 2 elements of Pythagoras or SOHCAHTOA. When you read the question, they're not telling you anything the diagram doesn't already show you. They're straight lines. That's on the diagram, so's that. But E is the midpoint of DB, which means if we knew what BD was, we could halve it. So let's find out BD. BD is in common. Let's focus on the right-hand triangle. 8.6 is the hypotenuse. BD is the opposite. We're going to kick off with a SOH question. We want the opposite. BD. They're next to each other. It's a times. Sine of the angle multiplied by the hypotenuse. And if the final answer is wanted to 1 decimal place, you must work in at least 2. I always go for 3 or 4-ish. Now you can take that forward. That's what BD is. You need to halve it so that you've got DE. All right. If you need to redraw at this stage, it's sometimes worth it. 4.4. It says work out the size of angle EAD. You can now stick an X in there. 5.528 halved, whatever that is. I didn't actually work it out when I did it. Oh yeah, 2.7. Tell a lie. I scribbled it down somewhere. It is 2.764. Come on. 2.764 is the opposite side. 4.4 is the adjacent side. O and A means we're now on to part 2, a TOA. You circle or cover up what you're after. If you want the angle, you cover up the tan. You're going to need to press Shift Tan, second function or whatever your calc's got, usually towards the top left. And we need to do opposite over adjacent, 2.764 over 4.4. Stick all that in your calc, not forgetting 1 decimal place required. My calc spits out 32.13, etc. So leave it at 32.1. And there we go. Number 13. Percentage multipliers. Again, very wordy, but it's all in the setup. I believe if you get the setup right on this, it becomes much easier. We've got the capital, 3,550. We've got some time. We've got the interest rate for 2 years. Earn your first mark. Write down the multiplier. If you want to increase something by 2%, your multiplier is 1.02. This has got a 6 on the end. We need a 6 on the end. It's for 2 years. We need it squared. She was paid R%. Now, I'm not going to call it R. R's what I'll think about right at the end. I'm just going to say a multiplier, because the way I'm doing it, I'm going to get an answer of 1 point something. That's not going to give us, R will not be 1 point something. R will be, well, it might be a percentage of 1 point something, but we're going to get 1.0379 or something like that, in which case R will be 3.7%. So we've got this multiplier that's unknown. I'm calling it X. And when it spits it all out, she ends up with that amount of cash. And that, I think, explains it nicely, because really what you need to do to find X is take your 3819. It needs dividing by 3,550, whilst also being divided by 1.026 squared. And obviously you're going to get a horrible decimal. That decimal is 1.021, and if my memory serves me right, there's about 4 nines there, but we're not interested. R is not the multiplier. R is referring to the percentage. You need to ignore the 1 and multiply this by 100, and you'll get to 1 decimal place. 2.2% is her amount of interest. And if you just stop for a second and go, does that seem a reasonable amount? You can realise absolutely yes, it does. But yeah, a very waffly question, a different take on percentage multipliers, but I think that line, all in one, nicely illustrates the best way, for me, of going about these questions. Number 14, I'll attack this in a similar way to what I did for number 13. It's amazing how you can use the same technique for lots of different circumstances. Feel free to read it all, but ultimately, it's one of them permutations, combinations. The idea is she can choose from 19 different body colours, 25 wheel types, and we don't know how many roof colours. But when these are multiplied, we have 3,325 possibilities. So as you can see, I'm going about it an identical way to the previous one, even though that was percentages, and this is combinations, permutations, and so on. Same thing. Find your x, take the 3,325 and divide it by 19 lots of 25. And again, like the previous question, do I get a reasonable answer? 7 seems fine to me. Number 15, when you're expanding 3 brackets, you just pick any 2 and expand them as you normally do. I always just go with the first 2. 3x times 2x, 2 times 1, and use your preferred way. If you like to do a grid for a 2 by 2, feel free. If you do loops, I do it by sight. I do the beginnings and the ends first, and now we do the middle. The x terms, that'll give us 3x. Those loops will give us 4x. So the middle for me is 7x's. I do advise drawing a grid, much preferred over loops. Not that you can't do it with loops, but if you're in an exam wanting every mark you can, why run the risk? It's a 3-mark question. You've got 4 or 5 minutes for this. No rush. When there's 6 loops flying around, stuff can go wrong. Whatever I've got on top needs multiplying by x, so that becomes a cube, that becomes a squared, and there we just stick it on the end. And now we need to multiply by -5, so times it by 5 and change the sign. Minus 30x squared, minus 35x, minus 10. And now we do that simplifying part. 6x cubed, there's no other cubes. For x squareds, we've got -30 of them, plus 7. And if you hate negative numbers, reach for your calc. This is where you can actually use your calc to help you with algebra. -30 plus 7 is -23. X squareds. Same again, use your calc if you need to. -35x plus 2 is -33x. And then you've got this plus c, the -10, on the end. Number 16, we've got 9 cards. Now, ways of getting an even or an odd product. When you multiply an even by an even, you get an even. An even and an odd, you get an even. An odd and an even, you get an even. An odd and an odd, you get an odd. So there's 2 ways of going about this question. You can either find the probability of these 3 and add them all up, or, as I'm going to do, even though it wants the probability of an even number, I think it's going to be easier to find the probability of an odd and just do 1 minus it. So what's the probability in 9 cards of me picking out 2 odds? There's 9 numbers. There's 5 odds. And if I've picked 1, there's now 1 fewer odd and 1 fewer card. Grab your calcs. No need to muck around. It's not a show question. Stick that in your calc as it is, and you're done. I was saying before about you've got 3 marks worth 4 or 5 minutes. This is where you save the time, because that's a 3 marker, but should be more like a 1 minute job, if you spot it, that is. Number 17, thankfully for this circles, theorems, angles question type thing, it doesn't say the old give reasons for each step. It says you must show you're working, and that means you are perfectly entitled to do most of your working out on the diagram. And also the bonus, don't need to give your reasons. Couple of things to notice first of all, B to O and A to O, they are both the same because they are the radius of the circle. We have an isosceles triangle. The angles I've just marked are equal. Next thing, O to A, C to D is radius and tangent. They are 90 degrees. They are perpendicular to each other. Now, if you never like angles questions, I would just say to you, stare at the diagram. Are there any more angles which you don't yet know? Well, can you work them out? Well, firstly, the angle there. Angles in a triangle make 180. So 180 take away 90, take away 32. That's worth 58. We've now got this angle we can find because it makes a straight line. Can't squeeze it in. 180 minus 58 means that angle at the apex of the isosceles is 122. Final step. It wants work out the size of angle CAB. So that's actually that angle there. Sorry, I said final step. It's not really. We'd now like to get these base angles. How do you find the base angles of isosceles? Do 180 minus the odd angle out, the angle at the apex. That tells you the total of these two. If you halve them, we get this little angle here to be 29. And now the final step. That angle of 29 and the angle C to A to B, I've just marked it with an X, they should make 90 degrees. 90 minus that 29 is 61. It's only worth 3 marks. That's why it's also a question where you shouldn't be giving your reasons. But as I say, the key to this, you must show all your working. It can be on the diagram. It's accepted as part of your answer. Mark schemes are very clear about that across all exam boards. Number 18, you can see the answer in purple. Let me explain how I get there. I've just cheated because me and technology are rubbish. Waffle at the top tells us nothing. 20% of the trees, well, 20% of what? We don't know how many trees there are. That's what we need to know. None of the trees have a height. Well, let's stop for a sec because let's just work out the areas of each of these. I'll call that D, so I'll use that as E. Let's just find out how much we've got. A, to find the frequency in a histogram, it's the area of each bar. The area of A, its width is 2.5, its height is 1.2. On your calc, times them, you just get 3. For B, width of 2.5, height of 2, times them, you get 5. Bar C, a bit more chunky. Width of 5, height of 2.8. Get them times. It's worth 14. And the final block, be careful. Doesn't have a width of 10 or 15. Its width is actually 12.5 and its height is 0.8. There we go. Now what we are told is that the missing bar is worth 20%, which also means the other bars, which have a total of 32, they're worth 80%. We'd like 20%. Divide by 4. Again, lots of ways of doing this. Could treat it as a reverse percentages question if you wanted to, but when the percentages are nice and friendly like that, why would you bother? Divide that by 4. There we go. 20% is really 8 trees. We need a bar with an area of 8. Area of 8, its width is restricted to 2.5. Divide area by width to give you the height you need to draw. 3.2. And in goes your bar, as you can see. There's 3.2. Job done. 3 marks, bit stingy, a lot of work on that, but not a bad question. Number 19 is pretty straightforward. Pick up your calculator. They've tried to catch you out. First of all, note in the formula, you use the radius. This is the diameter. Straight away, halve it. The radius is 4.2. All right, halfway across is 4.2. And now you just reach for your calc. What are you going to type? The formula is 4/3 multiplied by pi multiplied by the radius cubed, but that's a full sphere. We're halving it. There'll be some smart Alex out there who wouldn't bother with the halving. They just call it 2/3. It's all good. 3 significant figures. Calculator says 155.1 whatever. 155, because we need to do as we're told. Number 20. Errors and bounds. We had one earlier, didn't we? A little one. Not as hard as this one, but this one's a strange one because it's one of them where you've got to work the upper and lower. C is 10.9. So it's been rounded to 3 significant figures, which means we need to go, again, up and down by a half. 3 significant figures is really like nearest 10 pence. If that was £10.90 or 10.9, you need to go up and down by 5 pence. There's your upper and lower bounds for C. Now it says by considering bounds. That means it's not telling you to find the upper or lower. It's telling you to find both and see what happens. Well, let's do both. Let's stick in onto our calculators this formula with the 10.95 inserted. We get, and I'll do full calc display, but you don't need to go that far. 1165469, which I've used the highest. That's the upper bound. Let's look at the lower bound. Same again, except we're going to put in the 10.85. And let's see what happens. Again, I've gone for full calc display, but really it's become a bit more apparent. Now let me ask you this, if you don't know what happened, because these aren't the most popular questions, they don't come up very often. If you were to round these off to 1 decimal place, 164.1, 159.7, what does that tell you? By considering bounds, work out a value of, it wants value, not values. At the moment, we've got 2 values. look at where they meet in the middle. And I don't mean the halfway point, I mean when you round off, because there's your instruction to get rounding off. If we rounded each number off to two significant figures, not three, because at 3, all right, it becomes 164 and 160, not quite the same. But notice they are the same now. It says give a reason for your answer. I would make the statement now, D equals 160 as both round. I don't normally write all these out, but these are quite, this only happened, I've done all these past papers and this has only come up a couple of times. It both round to 160 to two significant figures. One significant figure, you lose a bit of accuracy, so keep it as accurate as possible. One significant figure, they're both 200, but that's too far away from the actual correct answer. You want to be rounding off where you get an answer above and below what you're getting. So it's a weird question, that. Hope I've made it clear, done my best. Number 21. Calculate the time taken to travel half the distance. Stop right there. It's not telling you what the distance is. There's your logic. Work out the distance first of all. Distance is given by the area under the graph. And it's a trapezium. Formula for a trapezium is a half, add the parallel sides together, and multiply by the distance between them. So do a bit of studying of your graph. You can see that the height of it, be careful, each one is actually 0.5. So the height of this trapezium from there to there is 12. The baseline is 100. The roof, so to speak, if you count it, is 50. Which means the distance, the full distance covered, is 900. Now that brings on the real puzzle. Whereabouts will half the distance be? Drop my pen. Here's the problem. It's going to be there somewhere. Might be there. Won't be as long. But there's just a guesswork. How do we know whereabouts? Let's first of all slice a little line in there. It's a bit off centre, but doesn't really matter. The idea is we're only focused on half. That'll be 450. Let's work out the area of this triangle first. Let's see how far they've travelled in this triangular phase in the first 30 seconds. The base of the triangle is 30. The height of the triangle is 12. 12 times 30 is 360. Halve it for a triangle. The area of that triangle is 180. So at what point do we cover 450 minus 180? What am I doing? At what point do we cover a distance of 270? But there's the good news. We already know the height of this rectangle. I'm just putting it in as a guesswork. We know the height of this rectangle is 12. What we'd like to work out is its width. 270 divided by 12 gives us a width of 22.5. There to there. Wherever it's going to be. That's in totally the wrong place, but it doesn't matter. So after 30 seconds, it needs to go another 22.5. You add them together, and there we go. Tricky question, that. Part B, I'll not scroll down. It gives compare the acceleration during this phase and this phase. And again, like always, they're encouraging you to waffle with 3 lines. You don't need to. I would simply say, well, the first bit is obvious in terms of the first phase is accelerating, the second phase is decelerating, but I'd also say it takes longer to accelerate to its full speed than it does to decelerate. It decelerates much faster. The downhill slope is much steeper. Or you could, again, it's always nice to talk in facts. It takes 20 seconds to decelerate to stop, whereas it takes 30 seconds to accelerate. Now, don't write everything I've just said. Just pick one of them. Mark scheme allows lots of different ways of that answer. Number 22. They're not very popular, these. I have lots of students who don't like these questions. They're easier than you think. You've just got an iteration. What does an iteration mean? It means when you sub something in, you calculate something, you get an output. That output goes back around and becomes your input. At the end of March, there are 200 rabbits on the farm. To get the next month, we do 1.2 times by March minus 50. We get 190. What happens after April? We get May. Repeat the process, but the output of 190 is now the input. So the 200 is no longer. Stick that in your calc. 178. We need another month though, because it wants the end of June. Repeat again. 1.2 times 178. Whoops, that's a 50. We all knew that. You get 163.6. You'll get some people who give the answer of 163 because you can't have 0.6 of a rabbit, should round down, and some people will round off to 164. The good news is Mark's scheme allows both. Whether you've gone for the it must round down approach or you've ignored the context and just gone for one, Mark's scheme's fine with both, so don't sweat it. Considering your results, well, as you can see, what will happen to the number of rabbits after a long time? In my worked answers, I've actually argued that basically they'd die out. But you could, maybe you don't want a sad story like that, so you just want to say something like, over a long period of time, it will continue and continue to decrease just by less and less each month. But I did put, eventually these rabbits are doomed. They're going to die out. Any words? But yeah, the Mark scheme again. Don't sweat it. Don't panic. It's all good. Just going to keep decreasing until there's no rabbits. That's a better way of putting it. Number 23, not the most friendly. Area of a parallelogram. That's the key word. When you want the area of a parallelogram, you need its height. And that ain't the slope. That's its height. I won't call it h because it's not the hypotenuse, so never a good idea to bring in letters that might conflict on formulas you're used to. I'm just going to call it x. I'll draw it off here. What that means is that 90 degrees gets knocked out. It's really a 60 that we care about, and there's a 10 minus x on the hypotenuse. So 10 minus x is on the hypotenuse. This side, which I've called x, probably should have called it something else. What I'm going to call it, though, is it's definitely the adjacent. That means we should be starting off with a bit of ca. I want the adjacent. I need to do cos of my angle times the hypotenuse. Right. Cos of my angle of 60 times by my hypotenuse. Trust me, It's not going to be as bad as you think, because don't forget sine 30 and cos 60 are both a half. It is just that. It does look ugly, but don't worry about it. That is your height of the parallelogram. We can now concentrate on area. Area of the parallelogram is the height, which we've just worked out, times the length of it, which is 2x minus 1, and you're told it's greater than 15. I'm going to double both sides and expand both sides. Now I am running out a bit of room, so I'll skip a couple of lines of working out. I'll just go straight to if you expand all these brackets, you do get minus 2x squared plus 21x, and to get that to 0, subtract 30. As I say, apologies for skipping a couple of lines of working out there. I'm just running short on room. Now, if you compare what you've got to what was there, it's close, but all the signs are different. Inequality is the other way around. You can either take them to the side or just times everything by -1, because that changes all the signs. And if you know about your inequalities, that flips inequalities around. Part B, find the range of possible values. You need to solve the equation in any way you're used to. I've already factorised it. I know I'm showing off. Whether you want to use the quadratic formula to get your critical values, feel free. You could complete the square, but I doubt anyone's going to bother with that. Quadratic formula or the AC method, they'll smash it. That means I'm getting two answers. It's a positive x squared. One of my answers is 8. One of my answers is 2.5. We are being asked, where is the graph below 0? It's below 0 between these two critical values. That's why the answer, it's not an equals to, so don't have equals. We need to be between our two critical values. Take a breath. Big 6 marker, that. Number 24 is a pretty messy question coming right at the end of your paper. It's sort of not far to go now. It's the penultimate, isn't it? Just one more after this. Quite a messy one, and only worth 2 marks. So one of them where you might just want to skip it for a bit and come back to it. But anyway, I've done the first bit. One of the 2 marks is dead easy. Draw that line, x equals -1, and reflect your shape. Now what that does is it means that the image of A is there. The image of B is there. The image of D is here. Image of C is there. The square is then rotated so that 2 of the vertices are invariant. Now, like I said, you've already earned a mark. Don't stare at this for loads. This is one of those questions where you might just want to go and check the rest of your paper. Go and have a good go at question 25 before coming back to this. This is one where, if you're stuck, do stick your hand up for a sheet of tracing paper, if it's not already been given out. And you can try it, but here's the key. What does the word invariant mean? Well, vary means to change, so invariant means the same. We need to rotate this shape to a position where 2 of the corners are still where they should be. Now, if you do some trial and error, you might start thinking that's a good one. But no, because B ends up being where C is and so on. None of them are in the same place. The square lies over the square. That's not what you're after. What you are after is the square to be either here with B and C not moving, or to be here, with A and B not moving. It is possible to get it elsewhere, by the way, but they're much more messy, so I'd go for them. Using your tracing paper, you'll soon see that's not the answer, but what is there. If you rotate this shape, let's get in that keyword, even though they've said it, it's always worth stating it. If you rotate that shape half a turn, in other words 180, about or around -1, 2, what will happen is it will flip upside down. The D will go to D. The C will go to C. That line will flip around and lie down there. The D and the C will be in the same place. The A and the B will not. The other correct answer is that's the centre. Because if you flip it 180 around there, the top line will go on top of the top line. And in that case, the A and the B will be invariant. And it's the C and the D that'd be up at the top. And they've changed. Very messy question, that, and one of them that can suck up your time. Do the easy bit and feel free to move on. Getting 1 mark on that is not a disaster, because you do need a lot of time for this big one. I will be skipping a few key steps here because I did nearly run out of space, but if you want it set out properly, do go and have a look at my worked answers, my PDF, scan them all in. Here I'm just going to talk you through what's going on, because there's a lot, and I do think 5 marks for this, pretty stingy. But anyway, let's stop moaning, let's get on with it. Whenever I see a straight line that's not in the form of y equals mx plus c, I get it in the form of y equals mx plus c. Subtract 3x from both sides, divide both sides by 2. Much better now, because the gradient and the intercept are now obvious. The gradient of line L is -3/2. So the gradient of the perpendicular, the gradient of line M, is the negative reciprocal. Flip that and change the sign. The gradient is 2/3. So let's now focus on line M. Not only is its gradient 2/3, it passes through that coordinate. The gradient is 2/3 and x is 0 when y equals 2. Let's look at our good old friend y equals mx plus c. Let's sub in everything we know. Well, if you sub in everything we know, y is 2, x is 0, so that disappears. Whoops. You actually get that the intercept is 2, but actually you really didn't need that because it tells you there. That means we've got the equation of line M. It's y equals 2/3 of x, and the intercept is 2. Take a breath. Line L crosses, let's now focus on line L. That's our original up here. When you cross the y-axis, another name for the y-axis is x equals 0. Let's take line L and sub in x equals 0. That means the x term disappears. You're left with 2y is 17. So y is 8.5. Next, lines L and M intersect. That's simultaneous equations. Good news. We know what M looks like. Y equals. We also have the original, the L, in the y equals form. Y equals 2/3 x plus 2. Y equals all this nonsense. Those two things are equal. You've got an awkward looking equation to solve. Do it your own way. Lots of ways of doing it. I'm going to times everything by 6, which means double, get rid of the 3 and double the top. That times 6 is 12. This multiplied by 6 means the 2's disappear and I just times the top by 3. Multiply this by 6. But do it your own way. I've just tried to be a smart aleck there, but it's now on a level and I can solve it. Adding 9x to both sides, subtracting 12 from both sides. I'm confident I'm doing it right when you get a nice, friendly looking answer. X equals 3. What does y equal? Well, pick either of your two equations, grab your calculator. Y is 2/3 times 3, which is 2 plus 2. Use your calc for that step. Again, take a deep breath. What the heck is going on? Because look at this. Work out the area of triangle ABC. This, people, needs a diagram. You are told that the coordinate of A is 0, 2. Stop for a sec. You've just found out where C is. It's 3 along, it's 4 up, there's C. If we reach back up to there, L crosses the y-axis at the point B. That's the coordinate 0, 8.5. And yep, it's now saying, what's the area of this triangle? It's easier than you think. The base is there, 8.5 minus 2, because the area of a triangle, it's certainly not half AB sine C. They're not that cruel. It's a half times the base. The base of this triangle AB goes from 2 to 8.5. The base is 6.5. And by naming that as the base, the height is that distance there. It's 3. Grab your calcs, take a deep breath, and now chuffing celebrate like you've won the lottery. Got to admit, early on there's some nice questions. Bit wordy, but they have been on at this era, just pre-COVID, isn't it? But some real tough ones at the end. Overall, I thought that was quite a tricky paper, if I'm being honest. But it is what it is. Good for revision, definitely. You're probably glad you didn't do this paper in 2019 because your reward is we're coming into COVID, aren't we? But there we go. So I hope that's helped. Time for me to shut up. Hopefully see you on the next one.